Hello everyone. So in this lecture, I will explain interview question on electrical machine. So some electrical questions which are frequently asked in the interview. So this first question is, what is back EMF in DC motor and why it is important? Then what is armature reaction and how to reduce this armature reaction? Then what is the difference between lap winding and wave winding? Then the why starter are needed for DC motor. Then explain the speed control of a DC motor. Then working principle of DC generator. So one by one I will explain this 6 question. Okay, let's start. First question. Okay, first question is back EMF. Back EMF in DC motor. Back EMF in DC motor. So what is back EMF? So when a DC motor rotates, its armature conductor cuts the magnetic flux of the magnetic poles according to the Faraday's laws of electromagnetic induction, and EMF is induced in the armature. So these induced EMF is called back EMF. So by using a diagram we will understand this. So if suppose these are the poles. This is a 4-pole machine. So we have considered a 4-pole machine, and in between, so there is armature, and these are the armature conductors. So here suppose, so these are the 4 poles. So because of that there is a rotating magnetic field. Now when its armature conductor cuts that magnetic fields, when this armature conductor cuts this magnetic field according to the Faraday's laws of electromagnetic induction, and EMF is induced in the armature, and that induced EMF is called back EMF. So why it is called back EMF? Why? Because it opposes the applied voltage. So we can say, like, the induced EMF means when DC motor rotates, then its armature conductor cuts the magnetic flux of the field poles, and according to the Faraday's laws of electromagnetic induction, an EMF is induced in the armature, and this EMF is called back EMF because it opposes the applied voltage. And this EB, that back EMF, is equal to that P phi Z N by 60A. So here P is the number of pole, then phi is the flux in Weber, then Z is the total number of armature conductor. So this is Z is total number of armature conductor, N is the speed, and A is the number of parallel paths in armature. Okay, this is the definition of back EMF. Now we will see why it is important. Why it is important? Because the first reason is it makes the motor self speed regulation. So what is the meaning of this? So here we will see, like, load. So there is a one factor, load. Then when this load increase, so in that case that speed will decrease. So when speed will decrease, then that back EMF is also decrease. Back EMF also decrease. So if back EMF decrease, then current flow increase. So now that current flow increase. So if current flow increase, then torque will also increase. Now if torque increase means speed recovers, so finally that speed recovers. So this is one condition. Now we'll see the opposite condition. Suppose now load decrease. So in that case what will happen? If load decrease, then speed will increase. Then what happened to the back EMF? Back EMF will also increase. Then that current flow decrease, torque will decrease, then speed will be stabilized. So that's why this because of this back EMF makes the motor self-regulatory by managing the speed. Okay, now we'll see the second question, that is what is armature reaction and how to reduce this armature reaction. So what is armature reaction? So in a simple or plain definition, we can say the effect of armature flux. The effect of armature flux on the main field flux. In DC machine is called armature reaction. Now we'll understand this elaborately. So to understand this, I need to draw two diagram. So first one is this north south. Okay, this is the simple diagram. So here there is a two axis. One is called GNA, geometrical neutral axis, then MNA, magnetic neutral axis. Now here there is this is north pole, this is south pole, and these are the flux. And in between that armature is there. Now in the normal condition, so these are called main field flux. So these are called main field flux. So this is main field flux. Now we'll see the armature flux. Okay, from the second diagram we can say, so these are the armature flux. So this armature flux. So there is a two type of flux. One is main field flux, another one is armature flux. Okay, so this is the third diagram. So which one is the combination of this first and the second diagram? So here we can see, so there is a two flux. One is armature flux, another one is the main field flux. So in the normal condition, so this main field flux is, so in this diagram we can see that main field flux is linking is proper. Now if we see the third diagram here, so there is a bending in the main field flux because of that reaction of that armature flux. So because of this, so there is a distortion. We can say there is a distortion. So this is the effect of, that armature flux in the main field flux. So because of that, so this is called armature reaction. So what are the main effect of this reaction? So it's distorts flux, then weakens that flux, even it shifts neutral axis also, shifts neutral axis, means if this is the that MNA magnetic neutral axis and similarly that GNA geometrical neutral axis. So because of this armature reactions, what will happen, sometimes it will shift that MNA magnetic neutral axis. So this is the effect of armature reaction. Now we'll see how to reduce this armature reaction. How to reduce. So there is three processes there. One is interpoles. Interpoles means by introducing some interpoles in between that main poles, we can eliminate that effect of armature reaction by introducing that compensating winding. Also we can reduce the effect of armature reactions. Third is by using that brush shifting. So this is the third process by which we can reduce the effect of that armature reaction. So this is all about that armature reaction. What is armature reaction and how to reduce this? What is the effect of armature reaction and how to reduce this armature reaction? Okay, now we'll see the third question. So that is, what is the difference between lap winding and wave winding? Lap winding versus wave winding. In case of a lap winding, the number of parallel paths A is equal to number of poles P, and more parallel paths, so more parallel paths, so each path carries less current. Each path carries less current. So the machine can handle large total current at low voltage. So machine can handle large total current at a low voltage. So that lap winding is equal to that, we can say that number of parallel path is equal to number of poles, means A is equal to P, and it has more number of parallel paths, so each path carries less current. So that machine can handle large total current at low voltage. Now we'll see the wave winding. So in case of a wave winding, that number of parallel paths A is equal to 2 always. Now fewer parallel paths, so as that number of parallel paths is less, so fewer parallel paths, each path carries more current. So as parallel paths is reduced, so each path carries more current at higher voltage. So hence we can say, so this is suitable for high voltage, low current application. So these are the difference between that lap winding and wave winding. In simply we can say that lap winding, A is equal to, in case of a lap winding and wave winding. So here A is equal to P, and in case of that wave winding, A is equal to 2 always. So and it can be, so this lap winding is used for large current and low voltage, and this wave winding is for large voltage, low current. So here number of parallel paths is more, parallel path is more, parallel path is less. So these are the comparison between that lap winding and wave winding. Now we'll see that fourth question, that why starters are needed for DC motor. Why starters are needed for DC motor? So why starter are needed for DC motor? So that main reason behind it, at starting motor is at rest, so back EMF is 0. At starting back EMF, that EB is equal to 0. So armature resistance is very low. Armature resistance RA is low. RA is very low, so huge current flows. As IA is equal to V by RA. If RA is low, then current will increase. So because of this, what will happen? So these can damage the armature winding. This can damage armature winding and commutator. So this is the effect of, like, because of that at starting, so as back EMF is 0, so that armature resistance is low, so huge current will flow, which can affect the armature winding and commutator. So to reduce this condition, that one starter is needed at the time of starting. So to reduce this condition, so at the time of starting, that one starter is needed. So if we see the diagram, so then we can easily understand. Suppose this is the DC supply, then this is the armature. Here we introduce a starter, like basically it introduces some resistance at the time of starting. So by using this knob, we can vary the resistance. So we can vary this resistance. This is starter, this supply. So this is the diagram, simple diagram. So by introducing that starter, basically we are introducing some, means we are inserting some resistance in series with the armature to limit the armature current. So the main function of this starter is limit starting current, by inserting external resistance. Second is provide safe acceleration. Provide safe acceleration. Third, obviously protect the motor. Sometimes provide protection also. Sometimes provide protection. So these are the function of starter. Okay, next, move forward. So in the next question, we'll see explains the speed control of DC motor. Now what is the speed control? So why speed control is necessary? So by which method we can control the speed of a DC motor? Okay, speed control of DC motor. Speed control of DC motor. So the speed control of a DC motor is given by N proportional to V minus IA RA by phi, where V is the applied voltage, this is the voltage, then IA is the armature current, RA is the armature resistance, and phi is the flux per pole. Now in a DC motor, that speed can be controlled different method. Here we'll see that field control method or flux control. First we'll see that this method, so that is field control method, field control method or flux control. Basically in this method some variable resistance is inserted in series with the field winding. Like from the diagram, circuit diagram, we can easily understand. So here is the supply, this is the armature, and this is the field winding. Now some resistance, variable resistance are inserted in series with the field winding. So by varying these we can control the speed of motor. So that principle is N proportional to 1 by phi. So by varying that field current, by varying the field current by varying the field current using a rheostat in series with field winding. And so this is the method. So this is called field control method, by which we can control the speed of a DC motor. So next one is armature control method. So that is armature control method. Armature control method. So here that principle is N proportional to V minus IARA, and V minus IARA. So here, by inserting external resistance in series with the armature, we can vary the speed of DC motor. So if we see the diagram, circuit diagram, so this is shunt resistance, and here that one resistance is inserted with the armature. So by varying this resistance, if more resistance means voltage drop. If there is a voltage drop, then armature voltage will be less, then lower armature voltage, then speed reduce. So speed will reduce. So in this way you can control the speed of a DC motor. So this is the speed control of DC motor. That last question is working principle of DC generator. That working principle of DC generator. So basic principle is that a DC generator works on Faraday's laws of electromagnetic induction. So it works on Faraday's law of electromagnetic induction. So whenever a conductor cuts magnetic flux, an EMF or electromagnetic force is induced in it. So whenever a conductor cuts magnetic flux, an electromotive force or EMF is induced in it. This can be, then we can write E is equal to BL V sin theta. So where V is the flux density, this is flux density, flux density. L is the length of the conductor, length of conductor, then velocity of V is the velocity of the velocity of the conductor. So V is the velocity and theta is the angle between conductor and flux. So that EMF equation, so equation for generated EMF, so that equation for generated EMF means EG is equal to P phi Zn by 60A. So where P is the number of poles, P is number of poles, phi is flux per pole, in Weber, then Z is the total number of total armature conductor, N is the speed of armature in RPM, then A is the number of parallel paths. Okay, this is the principle, that working principle of DC generator. So this is all about some interview question of on electrical machine. So in my next lecture, I will give some idea about that, some question on like other machines and transformer. Okay, thank you.